Hello everyone, welcome to this video on data structures in C. My name is Ayushman. Today we will be focusing on two fundamental structures which are linked lists and stacks. In this presentation, we will break down what these data structures are, how they work, and why they are so important for efficient data organization and manipulation. Let's start. Let's start by understanding what data structures are. Data structures are models used to organize or store data efficiently, or methods, we can say methods used to organize, store data efficiently. Efficient data storage is crucial for optimizing algorithms and handling complex data more efficiently. So now the second question which arises in our mind is why this is so important. Imagine trying to store or manipulate a large amount of data without the right structure. It would become slow and inefficient. By selecting the appropriate data structure, you can improve the performance of the code as well as significantly. In this video, we will focus on two key structures which are linked list and stacks. Majorly two data structures we are studying in this are linked list and stacks. So next slide. First up, in the linked list, so what is linked list is the first question which arises in our mind. It's a linear data structure where each element, called a node, contains both data and a reference or pointer to the next element in the sequence. The major advantage of linked list is the flexibility, or unlike arrays which have a fixed size, linked list can grow, shrink dynamically and depending on the needs of the application. Then, and also because of linked lists allocate memory as needed, they avoid the wastage of unused memory, which is common in other data structure like arrays. So linked list, we have studied a definition, which is linked list is a structure with nodes, then flexibility, having a very dynamic size which adapts or change data needs, then memory efficiently. Memory efficiency, we can say, allocates memory as it's needed. Let's dive into the structure of linked list node. Each node has two key components. First, the data, which stores the actual value. Then second, the pointer, which refers to the next node in the sequence. Here's a simple C code which will explain the demonstrate or structure of the linked list, which is struct node int data, then struct node next. Here, struct node we have used as linked list variable. Now, the node components which are used is data, the stored value, and the pointer, the reference to the next node. Mm. Now let's discuss the main operations which you can perform on linked list, like insertion, deletion, or transversal. The three operations we have listed here, which are insertion, deletion, and transversal. By discussing this, we can this all perform in the linked list. Like insertion, in short, I have written here like adding elements at the beginning, end, or middle. In deletion, we have written removing elements from any position efficiently, or transversal is accessing elements. So in detail, what we can see, or in detail how we can study is, you can add elements at the beginning, end, or at any position within the list. This is especially useful compared to arrays, where inserting an element in the middle requires shifting all the subsequent elements. Like in arrays, we know that while adding an element in the middle, we need to subsequently move all the elements aside so that we can add the element in the middle. So this is called insertion, and it is like advantage for insertion in the linked list. So we can add elements in the middle and at any position easily. Then deletion, second point. Similarly, you can remove the elements from any position without need for shifting. We don't need to shift any of the element in the list to delete any of the element present, like on the desired position 1, 2, 3, 4. We want to delete the element. We can easily delete that. No need to shift other elements like nearby elements 5, 6 to other sides. So you can just update the pointers to maintain the chain. We'll just update the value that this is 3, this is 4, then we'll can delete and again we can update. This is called deletion, and as compared to arrays, it is very easier in the linked list. Then transversal, traversal. To access the elements, you start from the head, the first node, and follow the pointers until you reach the last node. This process is called as transversing, tra traversing the list. Linked lists provide flexibility and efficiency when working with dynamic data sets. Next. Now let's shift to our focus to stacks. A stack is another type of linear data structure, but it operates based on the last in or first out principle, or LIFO, LIFO we can say. Think of stack of books. You just only add or remove books from the top of pile. This is how stacks work. The key concept of stack is that you only access top element at any given time. You can add elements but always on top and remove them in reverse order. Like stack, what we has defined is linear structure following last in first out principle. Then analogy is like stack, like which we are given example like stack of books. We can remove or add from the top or in the reverse order. Then key concept, one only top element is like accessible at any time. Then stack have three basic operations that you will commonly use in C: push, pop, peek, or in peek we can also say that top. The three operation which we are commonly using in stack, like first of all is the push. This adds a new element to the top of the stack, like adding a book, like a book pile is there, book stack is there. You just keep the book on the top of the other books. So that's as same. This adds a new element to the top of the stack. We can add the element only on the top of the stack. Then pop. Pop means removing the element from the stack. This removes the top element from the stack. Like if a stack of book is there, you will pull out one book, the book which book will be easily accessible to you, like the top one book which will. So that's why this is also the pop does the same work. This removes the top element from the stack. Now peek, this lets you view the top element without actually removing it. Stack operations are widely used in scenarios where you need to manage data in specific order, like when parsing expressions or managing recursive functions. In stack operations, we've used push, pop, peek. Easily accessible. Add push means adding to top of stack. Remove pop means remove the top element from stack. Peek means access the top element without removing it. Peek means just seeing. Then applications and conclusion. Now let's look at some real world applications of linked list stacks. Like first of all, linked lists are highly useful when you need dynamic memory allocations and efficient insertion or deletion operations, such as managing databases, handling file systems, creating dynamic data structures like queues. There, these are used. Then stacks are essential for expressing parsing, such as evaluating mathematical expressions or managing the function full stack during program execution. Now, in conclusion, both linked lists and stacks are foundational data structures that are critical or effective data management in C and beyond. Understanding how to use them will help you to write more efficient and organized code. Thank you for watching. I hope this gives you a clear understanding of important concepts in data structures. Thank you.